The Rooftop Garden Club is sponsoring a bake sale tomorrow, Friday, November 3rd. There will be cookies, brownies, and cupcakes, so make sure you bring some coin for that. Fine Arts Night is November 29th. Please enter the T-shirt design contest. See Mr. Lacks for details. Reminder that tomorrow is the last day for the grass holiday. If you're interested in that, make sure you attend it. Great time. On Tuesday, the senior boys soccer team defeated Glen Eagle by a score of 3-0 in the first round of the Fraser Valley playoffs. The boys now advance to play at Fleetwood Park today at 3 o'clock in the second round. The senior boys are reminded that their bus leaves at 1 o'clock and they are dismissed from class at 12:50 with their teacher's permission. Pheasant football fans, the varsity football team is playing its final regular season game on the Panther field this Friday versus GW Graham. This game is for the Eastern Conference title. It is also senior day. It is also senior day? Okay. As it is the last game for our grade 12 players. Please come out and cheer on the Panthers to victory. There will be a boys rugby meeting for anyone interested in playing this year. Please come on Monday, November 6th at lunch. See Mr. Klinger in his room A106. Girls, if you are interested in playing rugby, there will be a brief 5-minute meeting today in Mr. Wimmer's Auto Shop. Easy for me to say. That's an A107 at 11:35. See Mrs. Stone if you are unable to attend that. Students in all grades and parents, you are invited to an information session on applying for scholarships. That will be in the library conference room at 6:30 p.m. The seminar will be run by Brittany Palmer, who won 35 scholarships totaling over $125,000. She will walk those who attend through a step-by-step process on how to find and apply for scholarships. Language challenge applications are here. Please see Mrs. McKenzie for more information. They are due this Friday. If you're interested in that, see her. A reminder to all those folks who owe us time for being late, and Mr. Stu and Ms. Webster, we've been very kind to you this morning. We weren't hauling you off to pack, but if you were assigned previously, make sure you attend today, and we'll be back at that tomorrow morning. Additionally, we are back on pack. So Aiden Cassia, Alyssa Boucher, Caitlin Davies, Denise Deal, Mark Desura, Chandy Dollywall, Maya Farah, Aaron Fernandez, Ladaniel Garcia, Ranveer Gill, Sukmanjeet Hans, Jordan Jones, Gavin Qatar, Bijan Jaden Murphy, Daniel Olmos, Skylar Redquist, Daniel Salazar, Olivia Schultz, Gervier Sidhu, Daniel Yuko, Mitchell Willems, and Brendan Williams, who are all reminding you to have pack today. And folks, have a great rest of your Thursday. Back to learn.
So all of you should be following along. I will go back to the first page right now. Anybody need to ask about 1, 2, 3, or 4? This is all already supposed to be done. Vertex, yo. Where? Yes. -3. Which method did you use, or do you care? Okay, so Vx equals -8 over 2, right? Right? So Vx equals -4, right? Oh, did I do that wrong? No, I did it right. So that's my x value, yeah? So -4 squared is what? 16. 8 times 4 is what? So -32, which is what? Okay. Anything else from 1, 2, 3, or 4? Lovely. There is 5 and 6. Everybody okay with them? Megan. All right, well, let's look at which method did you use? Complete the square. Okay, so that's y plus 2, because I moved that over, right? Equals 2 x squared minus 2x, right? Factor out the 2. What's half of 2? What's 1 squared? Plus 1, right? Now I added, what's 2 times 1? 2. So I added 2 to this side, didn't I? So what do I add to this side? Plus 2. So now I have y plus 4 equals 2x minus 1 squared, right? When the plus 4 comes back over here. Yep. Anything else from the first page? Once? Twice? Thrice. Excellent. Congratulations, Max. By the way. This second page, I'm just showing you the answers because of time. It's another sad parabola. As long as you know the vertex is 3, negative 2, you should be able to figure it out, right? You should be able to figure out the points. This one is... The vertex equals negative 1, negative 4. This one is anybody need to ask about 7, 8, 9, or 10? Pardon me? 10 and 8? Okay. Which method do you use, Max?
I use the complete square.
You complete the square? Okay. So, y plus 11, right, equals, take out a negative, x squared minus 6x, yeah? Right?
Oh, yeah.
So I factored out a negative. What's half of 6?
3.
What's 3 squared?
9.
Plus 9. So how much should I add to this side? This is tricky. Negative 9, because there's a negative out in front, right? So this is minus 9. So that's y plus 2 equals negative x minus 3 squared. Y equals negative x minus 3 squared minus 2. Okay? Negatives are going to be there, guys. Half of the numbers in the universe are negative. You have to get more comfortable with negative numbers. I'm sorry. You just have to. Okay? You should have been taught them in grade 5. It's not your fault that you weren't. You were taught them much later than you should have been taught them. But that doesn't mean you get to not learn them. That's like saying I'm not going to learn how to turn left in my car because it's difficult. I'm only going to make right-hand turns. At some point, you got to make a left, right? You can't just keep making 3 rights your whole life. Okay? Everyone okay with that? Oh, just curious, you want to see 10. What method did you use? Oh, you used the BX, right? Okay. So that's A, that's B. So the vertex x equals negative b, negative 4, over 2 times negative 2, yes? So what is that? Negative 4 over negative 4, right? So the vertex x is positive 1, yeah? Okay. So that means what goes in there? What's 1 squared? Times negative 2? Negative 2 plus, what's 4 times 1? 4. What's negative 2 plus 4? 2. So my Vx was 1. So my V is 1, 2. So now I write it in, in vertex form. Y equals, got to factor out that 2. Negative 2, right? X, sorry. Yep. X minus 1 squared plus 2. Yeah? Okay. 11 and 12 are there. 13 and 14 are... I imagine I'm going to need to go over these. Y equals x minus 3 halves squared plus 7 fourths. So the vertex is 3 halves, 7 fourths. And this is y equals negative x plus 5 halves squared plus 3. And the vertex is negative 5 halves and 3. Does anybody need to see 11 through 14? And before you all yell 13 and 14, I know I need to go over them.
I was close, but I didn't get fully. I got 9.
Okay. Anything else? Do people need to see 13? Okay. Which method, Max, you're complete the squarer, yes? Okay. So, let us complete the square. Y minus 4 equals x squared minus 3x. Now, you're going to, I don't know if you did, because I've taught you before and you know how much I hate decimals. I'm going to assume you wisely did not go to decimals. Good man. Because 3 divided by 2 is simply 3 over 2, yes? And then squared is simply 9 fourths. Very few of you in your head could tell me that 1.5 squared is 2.25, although you should be able to. So this became plus 9 fourths, yes? Once I add 9 fourths to that side, what do I got to add to this side? Plus 9 fourths. Now again, fractions cause you guys to cry and lose your bladder control a little bit. You don't need to. Negative 4 plus, this is 1 3/4, yes? What's negative 4? Actually, sorry, it's 2 1/4. Sorry. I gave myself away because that's the next answer. What's negative 4 plus 2? Negative 2. And then I got to go another quarter towards 0 from 2. So that is negative 1 3/4. Right? So then this side, what I have now, is y minus 1 3/4 equals x minus 3 halves squared. Bring that over. Y equals x minus 3 halves squared plus 1 3/4, which is the same as plus 7 fourths. Okay, now the problem with this is I don't know where you went wrong. I can just show you how to do it, right? So you need to be, that's why I'm being so mean to you guys when you do messy work, right? Because if you can't follow your thinking to find out where you went wrong, two problems with that. One, how can I possibly help you with where you went wrong, right? If you can't find where you went wrong because your work is all over the place. Second thing is, if I'm marking it, how can I possibly say how much of it you did right? Okay. One of the complaints I get sometimes is, well, Mr. Myers, you handed me back this test, and you just told me it's wrong. You didn't tell me where it's wrong. I say, it's because I don't know where you went wrong. Because you don't have any sort of logic to your work. It's just numbers on the page. All over the place. If you look back in my notes, do you ever see that? I work vertically, right? So you can always follow the steps. Do you need... Megan, you wanted to see 14, yeah? Okay. And you're complete the square? Okay. So this comes over here, yes? So I have y plus 13 over 4 equals negative x plus 5x. Because you got to bring that negative out, right? X squared. Now, do you go to decimals? Good girl. So that's 5 halves squared, right? Which is 25 fourths. Correct? Okay, so what did I add to this side? Negative 25 fourths. So I got to take away 25 fourths, yes? Well, there was 13 fourths. Taken away 25 of them. That leaves me with negative 12 fourths, yes? What's 12 divided by 4? Negative 3. Right? Equals negative x plus 5 halves squared. And then you're going to bring that 3 back over and get y equals negative x plus 5 halves plus 3. Okay? So everyone is good with this?
Can you just go up to the number 7, just so I see the answer?
Of course I can. And this has all been recorded, so you can always go back and check. Is everybody good? Certainly. Right? What's half of 2? What's 1 squared? Plus 1, yes? How much did I add to the right side? So what do I add to the left side? Right. There you go. Y minus 2, because of this negative out in front, yes? There we go. Y minus 2 equals negative 2, x minus 1 squared. And then you bring that back over. Everyone good? Please be aware that having both methods available to you is better than relying on one. Understand? That is why I always say you can make your choice. The problem is too many of you choose one method and ride it to the end. Even though this question I find to be much easier as a complete the square. Right? Everybody cool? All right. Let us move on then, cabbages. I promised you guys that because today was a short day and we were going to be going over marking stuff, and because you have a quiz coming up on Friday, that we would do some review for that quiz specifically. Yes? So if you wish, you could get out some of your own paper right now, or more likely, you should just pay attention because you already have all of this in your notes somewhere. And a great many of you have a lot of trouble paying attention to what's going on and writing stuff down. Picking up what I'm putting down? Also, this is being recorded, so you can check on it later tonight. Okay? So it's up to you. You want to write this down, write it down. But I would recommend just paying attention. And when I say pay attention, I mean pay attention. When I ask a question, think in your head what the answer is if you don't feel like saying it out loud. But actually have something in your head. Okay? All right. So, what algebraic methods do we have for finding the roots of equations? Before you even can answer that, you have to know what a root is, yes? What is the root of an equation? Is it an x value? Is it a y value? Is it an intercept? Is it a vertex? What is it? Everybody think for a moment. Cole. Yes, they are the x-intercepts. Now, we know all kinds of stuff about the x-intercepts, right? They are always x0, which gives us a y value all the time, right? We also know that our calculator has a different name for them. It doesn't call them roots. It doesn't call them x-intercepts. What does that graphing calculator call them? Who remembers? Zeros. These are also the zeros because our output is 0. We are looking for the number that will give us 0. Everybody cool? All right. So what algebraic methods do I have of doing this? So what can I do with a pen and pencil and paper that will find me the roots? What? Quadratic formula. When does the quadratic formula work? Always. Why is it sometimes not the best? Why, Burke? Yeah, it's really detail-oriented, isn't it? Even if you don't memorize it, because you never have to, I'll always give it to you. But it's really finicky, right? You put a negative in the wrong spot, you're screwed, right? So the quadratic formula always works. When should we use it? Yeah, if you've got decimals, I really recommend using it. Or if you can't factor. What other methods do we have? Completing the square gets me my roots. Wait, does it? If I complete the square, don't I end up with, come on, don't I end up with x minus p squared plus q? Don't I? Yeah, equals y, correct? Well, don't I have a y value? 0, yes? So couldn't I use complete the square to find the x? Just doing algebra? Okay, so complete the square does work. You said it worked, and then I said, does it? And you said, no. Does it? Yes. And what's the third method we have to find roots? Plain old factors, right? If I can get the factored form, which is x minus p, or x plus p, x plus q, equals y. Then the y equals 0. So all I need to find out is x plus p equals 0 and x plus q equals 0. Right? Everybody cool? You got all three of them available to you. Now, a few of you only care about the quadratic formula, and that's fine. Go ahead and use it. But remember, you have to be careful. So, look at that question right there. What would you use? Why? You like it, okay? But let's pretend you're me, and you are equally confident at all three of these. Which one should you use? You would complete the square even with a negative, even with an odd number there? Because to complete the square, I got to factor out a 3, don't I? So this becomes 3x squared minus 8/3 plus 7/3. You would want to complete the square there? I'm just saying, would you want to? Because half of 8/3, right? That's 8/6, and then you got to square that, so that's 64/36. Do you want to do that? Could you? Is it doable? Yes, but would it be the best way to do it? No, so complete the square is probably no good. Can I factor that? Think back to the second unit. What's 3 times 7? 21. What are the factors of 21? 1 and 21 and 7 and 3. Do any of them add to 8? So factoring's out. So what's left? Quadratic formula, just like Sukpal says, right? So what would it be? I don't remember the quadratic formula, Mr. Mars. That's okay. I wrote it on your quiz. X equals something went on out there. Negative b plus or minus the root of b squared minus 4ac over 2a. That will always be given to you. I will never make you memorize it. Then all I got to do is know what's what. A, B, C. It mightn't hurt you to write it down. A equals 3. B equals what? Negative 8. C equals what? 7. Now put it over here. Negative B. B is negative 8, right? So negative 8. 8. Plus or minus the root of b squared. What's that? 64 minus 4 times 3 times 7. Correct? Over 2 times 3. Which equals 8 plus or minus. What's 4 times 3? 12. What's 12 times 7? 84. 64 minus 84 is negative 20 over 6. Are there roots? Are there roots? No, why not? Negative discriminant. So there are no roots. So what's your answer? No real roots. Right? What does the discriminant tell us about the nature of the graph? What is the discriminant? You need to know that. It's b squared minus 4ac. It tells us the roots. How do you remember that it tells us the roots? Where does it live? Under the square. Under the square. Say it loud and proud. Under the square root. Yeah, you said it too quiet. No way Jeffrey heard you say root. No, don't be that way. It gives us the roots because it lives under the root. Right? If it's greater than 0, how many? 2 intercepts. If it equals 0, how many? 2 equal roots, so 1 intercept. If it's less than 0, how many? 0 intercepts. So, how does that look? If it's greater than 0, the graph looks like this. Or this. It hits twice. If it equals 0, it hits once. If it doesn't, if it's negative, it's way up there or down there and never crosses. Everybody cool? Now, I just asked you, we're going to use the same equation, but we already know there's no real roots. So use this discriminant, b squared minus 4ac. 64 minus 4 times 3 times 7. equals negative 20. Negative 20 is less than 0, so no roots. Right? And that is everything you need to know for the math side of your upcoming quiz. Now, is there another side to math? Does math affect, or can math be used in the real world? Yes. So let's have a look at that. Reality and math. Okay? Let's have a look at this question. A ball is thrown vertically upward from an apartment building. The ball falls to the ground. And this equation gives me its height. If I throw a ball in the air, I lie. What path does a ball follow if it is thrown into the air? Up and then down, yes? So in reality, if it is thrown from the ground, it's going to go up and come down, right? Everyone agrees? Okay. That's math, right? If I put that on a graph, that parabola could be anywhere on the graph, couldn't it? Right? I could put this parabola anywhere. Right? But this is not math, is it? This is a real life situation. It's thrown upward from a balcony. So could it start from the ground? No, it's got to start from a balcony. Damn it. So where would I put that on my graph? You guys all took grade 10 math. Where would you put the two things that you are graphing here? What are the two things you are graphing? While you think about that, while my computer decides whether or not to erase that line, what are the two things that you are graphing? Pardon? Height and time, yes? In the real world, what measures are not allowed for height? Negatives, right? Because height ends at the ground, correct? So I can't have any y values less than 0. What about time? I can't have time less than 0. I cannot throw the ball so fast it goes back in time to before I threw it, can I? So I can only use this part of the graph, right? Did I start at 0 on height? No, I started on a balcony, so I had to start somewhere up here, yes? And did I throw it straight out? No, I threw it up. So as I throw it up, it's going to get height, and then it's going to come down. Will it go beyond that? If I graphed it as a math equation, would all of this red be on it? For how long? Forever and ever and ever. But since this is not a math equation, this is a physics problem, what's the only part of the graph I care about? The positive, quadrant 1, right? So how would I do that? What are you going to do? I want to know when the ball hits the ground. So that must be right there, yes? What part of the parabola is that? There's 3 names for it. That's the x-intercept, isn't it? Right? So it's the root, right? So I must have to use one of my 3 methods to find the root. Which one are you going to use with that? Damn right you're going to use the quadratic formula, right? So you can use your calculator. Now wait, let me ask you this. Could I take that and put it into here? Could I put that in there? And then I could use this, couldn't I? Is this allowed to be used if you have it and you're good with it? Yeah. Do you need to? No. But you got to be smart, correct? So if I was going to do this and I didn't have a fancy graphing calculator, what would I have to use again? Quadratic formula. What would it be? What's A? Negative 4.9. What's B? 14. What's C? 22. Fill it in. Negative B, negative 14, plus or minus the root of B squared, 196, minus 4 times A, negative 4.9, times C, 22, over 2 times negative 4.9, right? And you just have to punch that into your calculator. Now, something weird's going to happen when you punch that into your calculator, isn't it? You're going to get negative 14 plus or minus the square root of 627.2 over negative 9.8, which is going to get me negative 14 plus or minus the root of 25 over negative 9.8, right? What's 14 plus 25? Or negative 14 plus 25, I mean. Is that a positive answer? What's a positive divided by a negative? So one of my x values is going to be negative, isn't it? And the other one is going to be positive, isn't it? Which one of those is the one I care about? The positive one. Because the negative one doesn't matter. But if I put this into my calculator, is it going to give me the whole thing? If I try to graph it on my calculator, will it give me the whole thing? Unless I change the window, right? To only look at the positives. Now, the point I'm trying to make here is a great many of you wish to do everything on your calculator. You desperately want to use this to make the graphs. But think how many steps that takes and how much stuff you have to do on the calculator. Or can you do this with a regular old boring easy calculator? Picking up what I'm putting down? All right. Let's look at another real life example, because again, this is a real life example. I run a talent show. I sell tickets for $10 each, 375 people show up. Right? Everyone agree? Easy peasy, yeah? So what are the two things I'm counting? People and tickets, right? What is dependent? Tickets. Right? Tickets is dependent. The amount of tickets sold depends on the people that attend. I'm putting on a talent show. My talent is eating Pop-Tarts. You going to pay? No. So which is the dependent variable? People, right? Tickets are independent, right? Because if no tickets sell, nobody's coming. So, what have I got here? Tickets are $10 each, 375 people show up, yeah? So, what have I got? If I raise the ticket price $1, I lose 30 people, correct? So do I know the ticket price? I do, right? My ticket price is $10, yeah? Right? So I start at $10. Correct? Okay. What happens to that price if I raise it by $1? Yes? Right? Every raise of $1 gets me how many, what does that make happen? Less people leave, right? So if I sell 10 tickets, or if I sell tickets at $10, I get 375 people showing up, right? So $10 times 375, yes? Everyone agree? If I add to the price, what happens to my people? I lose some of them, correct? Right? If I raise it one raise, how much do I lose? 30. Everyone agree? Everyone agree? If I raise it $2, how much do I lose? I lose 2 times 30, correct? Right? Everybody with me? What if I raise it $3? How much do I lose? 375 minus 3 times 30, correct? What if I raise it $4? 375 minus 4 times 30, correct? Is everybody with me? What if I raise it X? Minus 30x. Doesn't that look like a factored form of a quadratic equation? So couldn't I graph that? And when I graph it, I will find out it looks like this, yes? Because I'm going to end up with a negative x squared, right? Is that a maximum or a minimum? Maximum, right? Does that maximum have an x value? Does that x value, can that be punched in here? So if that x value was 7, right? Then what is my ticket price? No. 17, because I started at 10. Now everybody says, when does math have a use in real life? If you have a little bit of data, look what you can do. I now know if I raise the price this much money, yeah, some people will leave, but the extra amount of money I charge the people that actually show up will get me the most money possible. Okay? This is what we need to be able to do. Now, I have a sneaking suspicion that you guys could use a little more practice with these things. Right? Because this is super easy on one of these. Should I go get them? Because it's a short day. I didn't want to do anything new today. Go get them and we can work these through? All right. You guys talk amongst yourselves. And then maybe you want a piece of paper out, or maybe you want to follow along. Because what we're going to do here is we're actually going to do this question with the graphing calculators. Yeah, I got what you need. Attention, please. You have an option. You can work through this with your regular, easy, regular to use calculator, or you can use your own graphing calculator, or you can bring me one of your devices and borrow one from me. I don't care what way you do, but we're actually going to work through this problem now. I'm going to give everyone a chance to use some kind of technology to actually come up with the right answer. Okay? Oh, I've lost the equation. Nobody is rushing up to get a calculator, so I assume you actually want to work through it. There it is. All right, so I want the maximum height, and I want when the ball hits. Okay? Does everybody have some kind of technology in front of them? All right, so if you are not going to work with the graphing calculator, then you need to do this question using A, B, and C, the way I wrote it out over here. If you are going to work with the graphing calculator, let's start working with it, okay? First thing I would recommend is I would look at this question, I would say to myself, self, what window do I need? I need positive numbers, yes? Everybody with me? Now, look at this question. What is the y-intercept? That's where x equals 0, right? X is t, 0, 0, 22. So what's the y-intercept? 22. And the ball is going to be thrown up from there, yes? So I need my maximum y value to be higher than 22. So I'm going to go into my window, and I'm going to set my y minimum. I'm going to set it to -5. Why are you setting any negatives, Mr. Myers? You'll see in a second. And I'm going to set my maximum to 50. Is everyone okay with that? Everyone cool? All right. Now, if I leave this y scale at 1, how many little ticks are going to be on my graph? 50. That's going to be busy, isn't it? So I'm going to change that y scale to 5. Now there's only going to be 10 ticks. Everybody cool? Now, what about the x value? X is time. Do I need negative time? No, I don't. So I'm going to make it -5 as well. And I need some positive amount of time. How long do you think it's going to take a ball to hit the ground if I throw it off a balcony? What would be a reasonable amount of time? Couple seconds. So do you think 10 seconds might be enough? And we'll leave it at 1 scale, yes? Everybody cool? So now my window will look like this. And the calculator screen will be here. Notice I've left a little bit of space so I can show my graph so I can see easily where it is. Because if I make this y value 0, where's the y-axis going to be? It's going to be on the very edge of the screen, yes? It's going to be hard to work with. So I've set up my window. You guys are welcome to figure it out on your own. I would rather sit here. But I know that tomorrow when I give you the quiz, you're going to be crying like babies that you want better marks. And yet, when I try to show you how to do it, none of you give a rat's ass. Yes, of course you would push y equals now, Jazz Carrot, and you would enter it. Now you must be careful here. What is that? Subtraction or negative? Negative. So what button do I hit? Subtraction or negative? Negative. Negative 4.9. Now, it's t. Well, that's even one of the variables it gives me on my calculator. T squared plus 14 variable plus 22. Can everybody enter that? It's gone off my screen, but you can see it all if I go back and show you. Negative 4.9 squared. Everyone's good? Yes. Then what do I push? Graph. And there it makes my nice graph. Now notice how, because I left a couple of negatives in there, it allows me to have this space. Okay? Don't do anything for a moment. Watch what happens if I change the window for my y maximum, my y minimum to be 0. See? It makes it really hard to find that because you got to go left and right of it, don't you? And because it ends at the edge of the screen, you can't go left and right of it. So I always like to leave a little bit of extra space on both sides, even though I don't need negatives. Now the question is, I need the maximum height. Where is the maximum height on this parabola? It's the vertex, yes? Excellent. So what on my calculator allows me to calculate things? Second calc. And what do I need? Maximum. So what do I push? 4. Now, the left boundary. There's my cursor. Is my cursor on the left of my vertex? So what do I do to put it there? I use the left buttons, just like playing Tetris. Have I gone over the vertex? Am I on the left now? So I can push enter. Now I need a right boundary. So now I move it to the right of the vertex. Have I gone over the vertex? Yeah, so I push enter. Now it says, do you want me to guess? Of course I do. Why do you think I'm pushing your buttons, you stupid machine? Enter. 1.42 x, y of 32. Which one of those is the height? The y, because the height depends on the amount of time since it was thrown. So what's the maximum height? 32. When does the ball hit the ground? Well, that must be the time when the height's 0, yes? So let's go to our calc. What one on there would give me that? It's not an intersect. 0, because I want it when it crosses the x-axis. 0. Left boundary. Right now, is my cursor to the left of the x-intercept? It's flashing there. There's the x-intercept. Could I leave it there? Sure I can. But I got to move it down there anyway to get the right boundary, right? So I'm just going to go ahead and move it down so it's a little closer now. Getting close, getting close, getting close, getting close. There we go. Enter. Now I got to go to the right of the x-intercept. How will I know when I'm to the right? What will happen to my height? It will change to negatives. Is it negative now? It's hard to see because my cursor's in the way. I'll hit it again. Is it negative now? So can I use that as my right boundary? So I can hit enter. And then I can hit guess. Yes. 3.98 seconds. Everybody cool? Now, Let's pretend you're bad with your graphing calculator or you don't have one. We had it written out earlier, didn't we? It was negative 14 plus or minus the root of 196. It ended up being negative 14 plus or minus the root of 25.2 over negative 9.8. Yes? Everyone agree? Okay. So now we know negative 14 plus 25. Do I even have to do it? No, because that's going to give me a negative value, right? So I don't need that. I just need this one. So I go negative 14 minus the square root of 25.2. Now I should have put all that in brackets, yes? Because I'm about to divide, aren't I? So I'm going to hit equals because I don't have the brackets. Divided by negative 9.8. 1.94. I did something wrong there. What did I do wrong? Oh, I know what I did wrong. This isn't 25.2. This is negative 4. Oh, yeah. No. That's right. Come on. Minus 4 times negative 4.9 times 22. Yeah. So 14, oh crap, bracket, negative 14 minus 5, we'll do 5. Negative 14. Anyways, negative 14. I need brackets. Bracket, negative 14 minus square root of it's not the square root of 25. Yeah. I'm just trying to the square root of 627, right? 0.2, close bracket. Oh, crap. But calculators are the easier way to do things, right? Bracket. That divided by negative 9.8. 3.98. And what did we have? 3.98. So you can do it with a regular calculator too. How do I find the maximum height with the regular calculator? That's my vertex, yes? So all I got to do is find the vertex here. How do I find the vertex? How do I find the vertex? Pardon me, Sukbal? No, 3.98 is a root. To do the maximum height, I need the vertex, right? The vertex x value is negative b over 2a, isn't it? Do I have b and a here? So that's going to give me negative b, negative 14, divided by negative 9.8, yes? 14 divided by 9.8? 1.42, yeah? Is that an x value or a y value? It's 4.3, thank you. It's an x value, so where does it go? in for the x's. But I don't have x, I have t's, right? And once I plug that in, I should get 32, shouldn't I? Negative 4.9 bracket answer squared plus 14 times answer plus 22. 32, 32. Everybody good? I know you're not, but that's okay. Without the graphing? I understand. I want you to be able to do both. Yes. It might be. It's parabolas. It's, I know, funny, hey? Probably shouldn't have talked the whole time I went over it, right? Okay. Well, then when I tell you it's on the quiz tomorrow, you shouldn't go, what? Because you get it, right? There you go. Oh. Says right there the quiz is on parabolas. Did this graph a parabola? So can it be on the quiz? There you go. See how that works? Let's do the second one. Once I get to there, if I want to use my graphing calculator, can I enter that into it? Yes. If I want to use a regular calculator, what do I have to do with that? Because I can't punch that into a regular calculator, can I? What do I got to do to that if you want to use a regular calculator? I got to expand it to get to the quadratic form, to get to the quadratic equation. Now there's a problem with that though, isn't there? Because when I expand this, I get 3750 minus 300x plus 375x minus 30x squared, yes? So I get 3750 plus 75x minus 30x squared, yes? Now, when that shows up, you're going to see the problem. What's A, B, and C if you're not careful? What's A? Negative 30. What's B? And what's C? Right? So when you punch that into your regular calculator, you got to remember, you've mixed up the order. But then once I'm there, can I use all the stuff I already know? Can I use Vx equals negative b over 2a? Yep. Can I use quadratic formula? Yep. Will I get the same answers? Yep. Everybody good? All right. If you're smart, you will go home tonight and you will make sure these videos make sense. I would go home if I were you, and I would change this value to h equals negative 4.9t squared to plus 18t and plus 12. And see if you could do it. And I would change this one to $12 each. And just change the numbers. Have good days.